Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the WebSockets module titled Cross-Site WebSocket Hijacking. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on WebSocket Labs and select lab number 3 titled Cross-Site WebSocket Hijacking. Alright, let's get started. This online shop has a live chat feature implemented using WebSockets. To solve the lab, use the exploit server to host an HTML JavaScript payload that uses a cross-site WebSocket hijacking attack to exfiltrate the victim's chat history, then use this to gain access to their account. And we've got a note right over here saying, to prevent the Academy platform from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. To solve the lab, you must use the provided exploit server and/or burp collaborator's default public server. Alright, so the target goal over here is to perform a cross-site WebSocket hijacking attack to exfiltrate the victim's chat history and then hopefully gain access to their account. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are being passed in my Burp proxy. I am using the professional version of Burp because for the first portion of the video, we're going to solve the exercise by using the collaborator functionality in Burp, which is only available in the professional version. But in the second part of the video, we'll use the exploit server, so you don't actually need the professional version to complete this exercise. So if you only have the community edition, stick around to the second part of the video. Alright, the first thing I'm going to do is click on live chat. Now notice over here, this is the page that we just requested, and then it calls a chat.js script, and then over here you could see it's switching the protocol to a WebSocket protocol. So anything that we type in here will no longer be recorded in HTTP history. It's actually going to be recorded in WebSockets history. And we already have an item over here. So our server sent this message over here, so ready, to the backend server. And so the backend server responded to us and said connected. And then it responded with this message over here saying now chatting with this person over here. So if we enter a message over here, hit send. This is us sending the message to the backend server, and the backend server responds to us, which is us, the client. It reflects back our message, and then it responds with typing, and then it sends the response to our message, which is, I am the fount of all knowledge, but sorry, I don't know that. All right. So over here, if we're trying to perform a cross-site WebSocket hijacking attack, essentially what we're going to do is request this page from the application. So this over here, .websocketacademy.net/chat. And essentially what we'll do is open that connection by sending ready to the server. And when the user clicks on our malicious script, it'll send the cookies with our request. And so the backend server is going to think we're authenticated as that user. And so essentially what it'll do is it'll respond with all the messages that were sent by the user. Because with WebSockets, it's bidirectional and there is no CSRF token over here to access this page. So if we say test 2 over here, or test 3, hit send, and then say test 4, hit send. This was the last request that was performed. Now let's go to home. This request would get logged in HTTP history, and then when we request the /chat endpoint, notice over here, it responds with all the messages that were sent. So the entire history that we had with this person over here. So it starts off again with ready, and then you could see over here, I sent a message test, and then it responded to that, and then I sent another message test 3, and then it responded to that, and then I sent another message test 4, and it responded to that, and so on. So if we could get the user to click on our malicious script, which requests this endpoint over here, and then obtain the response of the request, which is all these requests over here, we could get the victim user's history. And if the victim user put anything sensitive in that history, then we might be able to compromise his account. Now, you might be wondering, well, aren't there coarse rules, so cross-origin resource sharing rules that prevent that? The answer is no, because when it comes to WebSockets, the connection is bidirectional, and so we could actually access the response. We're not just performing the request like with traditional cross-site request forgery attacks, where we only can perform a request. In this case, we perform the request and then we also access the response, which makes it much, much more dangerous. All right, so let's write out our script over here. So we'll say script, and then we need to initiate a new WebSocket connection. So we'll say var ws is equal to new WebSocket. And when we're initiating a WebSocket URL, we'll say WSS, and then the URL that we're requesting, which is just this one right over here. So you could see over here, it's to the /chat endpoint. So let's just copy it from over here, copy link address, and put it in here and remove the HTTPS. All right, this looks good. Let's add a semicolon, and then we're going to say ws.onOpen is equal to function, and we'll say ws.send ready. So the reason we're sending the ready message over here is because if you look at the first message that is sent from the client to the server in order to view this history over here or to start connecting with the client is ready, and then that's when the client responds to us. So essentially what we're doing is trying to open a connection to the server. Now, when we do open a connection to the server, what will happen is the server will send us the entire history of our chat or the chat of the victim user that we're phishing. And so we need to be able to retrieve all these responses. So we're going to say ws.onMessage. So whenever there's a response from the server, function, event, I want you to fetch this URL over here. And the way you fetch it is using the post method. So we're going to say method post. The mode is going to be no course. So this just prevents a client-side error from getting outputted, but I believe it shouldn't hinder the attack if you don't include it. And then we're going to say body is event.data, and then we'll add a semicolon. So essentially what we're doing over here is we're saying whenever there's a response from the server to the client, I want you to ping my attacker controlled server, and in the body of the request include the message that was sent from the server to the client. So for our attacker controlled server, we're going to go back to burp. We're going to go to collaborator, click on get started, copy to clipboard, and put it in here, say HTTPS. And so right now, every time we get a response from the server to the client, it'll ping our attacker-controlled server, and in the body of the request, we'll see the message. And the messages we're going to see are essentially the ones we saw in WebSocket's history. So for example, over here, the user, the content, and so on. All right, let's copy this. Now we need to send this to the victim user, and the way we're going to do that is using the exploit server. So this is just an attacker-controlled server that is available, let's say, online, and then we're going to send this link to the victim user, And then the victim user is going to think this is just a normal website, but what's really happening is there's a malicious script that performs a cross-site WebSocket hijacking attack in the user session and retrieves the entire history of the live chat of the user. So deliver exploit to victim over here. And if we go back to burp and to collaborator and click on poll now, we don't get a ping back, which means there's something wrong with our script. So if we go back right over here and review the script, and I know what's wrong over here, I set an equal sign when it should be this character over here, which is similar to the method and the body. So that probably caused a JavaScript error, which prevented it from running. So let's deliver the exploit to the victim user again. Go back over here and click, oh, and we don't even have to click on poll now. You could see right away that we got a ping back from the IP address 34.253.173.2, and that's likely our victim user account. So if we click on this one right over here and look at the body of our post request, you could see this was a message that was sent from the automated user. Now we're looking for the victim user messages. So let's go down over here. Interesting. So this says no problem, Carlos. And we get a bunch of random characters. So my guess is this is a password. However, let's look at the rest of the messages because it's likely that we're getting these messages out of sequence, and that's why we don't understand the full story. So if we look over here, it says you, which is the victim user, says I forgot my password. And then it looks like, if we look at the rest of them, here we go. So the victim user says, I forgot my password. And then the support person says, no problem, Carlos. So we know the user is Carlos. And we know that this is Carlos's password. So let's copy this. And actually, before we enter it in the lab, so you have to go back over here and log in using Carlos's account. Before we do that, we're going to move to the second part of the video, which is complete the script using only the exploit server. Because if we do log in as the Carlos account, the exploit server will disappear and we'll have to wait for a new instance of the lab before we could solve the exercise. So what we're going to do right now is create a new script that purely uses the exploit server. So I'll say this is for Burp Collaborator or Burp Suite Professional. And this is for Burp Suite Community. All right, and I'll leave the link to this document over here in the description of the video. So essentially what we're doing over here is we're pinging our collaborator server, which if you don't have Burp Suite Professional, you don't have access to. So instead what we're going to do is ping our exploit server. So let's copy this, paste it in here, add a random variable. So let's say comment is equal to, and then over here, we're just going to remove this entire thing and just append event.data to it. Because essentially what we're doing is we're going to access the access log, and anything that gets logged in the access log will have access to it. And in the access log, you won't be able to see the body of the post request, and that's why we've converted it to a get method. And then you'll see in the URL the response from the server. So this should work. Let's copy it, paste it in here, deliver the exploit to the victim, and then go to the access log. And so far, we don't get a ping back from the victim user. This is just the IP address of my VPN. Hit send. And it doesn't look like the victim user is accessing it. Now, to know if this exploit actually works and the error is from the lab itself, what you could do is view the exploit. So now it's running within your own session, and so it should display the messages that I sent, so the history in my live chat. So if we go back right over here and click on access log, it looks like it's not displaying the messages, which means something is wrong. And I know what it is. It's another syntax error. So over here, we left a curly bracket that shouldn't be there. So let's copy again. So let's go back, paste it in here, deliver the exploit to the victim user, click on access log. All right, so you could see over here, these are all things from the victim user. And as you can see over here, we've got the content in the URL instead of in the body of the post request. So it says over here, it looks like I forgot my password. And then over here, it says no problem, Carlos, and your password is right over here. So let's copy this again. And we know the victim user is Carlos. So let's go back and go back to the exercise, click on my account, go to Carlos, and then the password is the one we discovered. Click on login. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by performing a cross-site WebSocket hijacking attack to exfiltrate the victim's chat history and then compromise the victim's account. This completes the exercise.